Welcome to our deep dive into the world of vaping and its impact on lung health. Today, we'll explore the science behind vaping, its potential risks, and recent research findings that shed light on the dangers of certain additives. Join us as we uncover the truth about vaping and why informed decisions are crucial, especially for young people. Vaping refers to the act of inhaling and exhaling vapor produced by an electronic cigarette, e-cigarette, or similar device. E-cigarettes work by heating a liquid which usually contains nicotine, flavorings, and other chemicals to create an aerosol that is inhaled into the lungs. Vaping is often seen as an alternative to smoking traditional cigarettes, but it has raised concerns about its long-term health effects, especially among young people. Research from Concordia University has uncovered the detrimental effects of vaping additives, specifically tocopherol, vitamin E, on lung function, contributing to a condition known as EVALI. The study utilized advanced techniques to illustrate how these substances disrupt the lung surfactant, crucial for breathing. This is especially concerning for young people, who are more inclined to vape, underscoring the importance of informed health decisions and regulatory oversight. Vitamin E binds to the pulmonary surfactant, hindering gas exchange and lung stability. While the health risks of tobacco and cannabis consumption are well documented, much less is known about the dangers of vaping, particularly flavored products popular among young adults. The issue is becoming increasingly urgent, with Statistics Canada reporting that 1 in 10 Canadians aged 20 to 24 and 1 in 15 aged 15 to 19 reported vaping daily in 2022. When heated and inhaled, the compound becomes embedded in the pulmonary surfactant, a nanoscopically thin lipid protein membrane that coats the alveoli surface. This membrane regulates the exchange of oxygen and carbon dioxide and stabilizes the lung's surface tension during breathing. The researchers used one-molecule-thick model membranes called Langmuir films to simulate the expansion and compression of the pulmonary surfactant. They then introduced vitamin E, which has a similar structure to the lipids in the membrane. Various observational techniques including microscopy, X-ray diffraction and X-ray reflectivity were used to observe how the additive altered the surfactant's properties and monitored changes as they added more, mimicking how a real surfactant would accumulate and retain the compound in the lungs. We can see that the presence of vitamin E changes the functional properties of the surfactant. Oxygen is exchanged for carbon dioxide across the pulmonary surfactant, so if the surfactant properties are altered, so can be the ability for gas to be exchanged. And if the surface tension is changed, that affects the work of breathing. So combined, these changes make breathing more difficult. We think this is the molecular basis contributing to the shortness of breath and reduced oxygen levels seen in people suffering from EVALI. Youth are particularly at risk, as vaping trends have a stronger influence on them. This research reveals critical insights into the potential short- and long-term consequences of vaping, empowering young individuals to make informed choices about their health and well-being. The researchers hope their work can inform regulatory bodies about the risks associated with certain vaping components, and whether these additives can impair lung function. Thank you for watching. Subscribe for more interesting scientific discoveries.